Okay, so today's question is special binary string. So special binary string are binary string with the following two properties. The number of zeros is equal to number of ones in that particular binary strings, special binary strings, and every prefix of the binary strings has at least as many ones as zeros. Okay, every prefix of binary strings has at least as many ones as zero. Okay, number of 1 and 0 in the prefix of the strings are equal, and you are given a special binary string as, okay, this is already a special binary string. A move consists of choosing two consecutive non-empty special substrings of s, a special substring of s, and swapping them. Two strings are consecutive if the last character of the first string is exactly one index before the character of the second index. Okay, and we have to return the lexicographically largest resulting string possible after applying the mention operations on the string. Okay, so we have to just rearrange this and return the largest possible special substring. So let's take this example 11011. Now you can think of it like the balance brackets, one for the open brackets and other one for the closed brackets. For this example, suppose one can be behave as the open bracket, so open, then again open, after opening it's close, then again open, then again open, then close and close. See, now we have got a balanced parenthesis. So this this is special binary string nothing but the balanced parenthesis. Okay, so let's try to code this using recursion. So suppose if lane of s is less than or equal to 2, we can't do anything, we can simply return s. Else, what if the length is greater? We can take the count is equal to 0. Count will keep track of we will put +1 for 1 and -1 for 0. So wherever this count gets 0, it means that particular substring is the special binary string. Now also we can take a starting index, start is equal to 0, and a part subarray which will store all the that is special binary substrings. Now let's try to code. So for I comma character in enumerate s, suppose if character is equal to 1, we can, as said here, we can simply increment count by 1. Else it's 0, we can simply decrement count by 1, count minus is equal to 1. Now suppose we got at some place count is equal to 0, that means we have got a special binary substring. So what we will do, we will simply go call recursive function for his inner loop. Okay, suppose this was whole balance. Okay, so in the inner one we will not consider the last and the first one, we will only consider this the inner part. Okay, so we will calculate the inner part. For inner part we will again call this function self dot this function we will call it recursively self dot market space make largest special, and then yeah, we will pass the string. It will start from start +1. We have defined the start here. For the first one it was 0, now start +1 till the index I. Okay, till the index I, yeah, and when we got this value we will simply append it. So part dot append, we have removed the first one here, we have started from start +1, so we will add the starting one here, then add the inner one, and then add the last 0. We have not taken I into the consideration here, the last index. Okay, and now we will simply increase the start to I+1. Okay, done. Start is equal to I+1. Now we would have got all the special binary substring in this part. We can simply sort this out to get the largest lexicographically resulting string. Okay, so simply part dot sort We have to sort in reverse order so that we get the largest at the top. Part dot sort reverse is equal to true. What it will do, it will keep ones at the ahead. Now simply you can return not to join, what to join this part, all the elements in the parallel. Try to run and check whether this works. Okay, invalid syntax at somewhere. Let's check. We are showing mistake. In is equal to self dot market special as, oh, we have this put it outside of the bracket. Now try to run. Okay, so we are getting wrong answer. Let's check what's the issue in our code. We have taken into the consideration the length of as less than equal to return as. We have declared correctly count is equal to 0, start is equal to 0, and part is this. Okay, now we have defined for I comma character in enumerate as. If character is equal to 1, correct, count plus is equal to 1, else count minus is equal to 1. Now suppose when a count becomes 0, what we are doing, we are calling inner is equal to self dot same function make largest special from s is equal to s of start plus 1. First start was 0, now start plus 1 till I, and then we are appending part dot append. Oh god, we have in place of plus we have put a equal to. Start is equal to I plus 1, and then part dot sort reverse is equal to 2. Now it should work. Let's try to run and check. Yeah, so test cases has passed. Let's try to submit and check. Yeah, so our code has passed successfully. Thank you for watching.